Ladies and gentlemen of Algebra 2 Honors, welcome to our 8th period class today. We are going to be building upon what we started on last week, Friday, which was solving absolute value inequalities. And there was a key like chant or mantra or something like that that helps us remember when to use which thing, which is, who remembers that? Six words total. Well, let's go ahead and work this first. I'm going to go look at number one, which is similar to what we did last time. So if we make a table and we're asked to determine whether each of the integers from -5 to 5 is a solution of this inequality, and so we can just list these integers sequentially. And the answer is going to be yes or no. And then we accordingly mark these on a number line. And so if we take -5, and we have -5 minus 1, which is -6. Thank you, Jay. And the absolute value of -6 is 6. And 6 plus 3 is 9, which is greater than or equal to 5. Yes or no? Yes. So that means that this integer value here is marked on our number line, number 1. And similarly, we go to -4. Well, -4 minus 1 is -5. And that becomes 5 plus 3 is 8, which is greater than or equal to. And you can see that if we take the similar thing, we're going to have yes, yes, yes. And -1, if we take -1 minus 1, that's going to be -2. And 2 plus 3, is that going to be greater than or equal to? It's going to be equal to, right? Which still qualifies as yes. And so all the way up to here, to x equals -1, each of these integers qualifies. What about when we plug in 0? No, because we'll get 1 plus 4, which is not greater than or equal to. So no, no. What is our first yes? Is 2 going to work out?
No.
No. Is 3 going to work out?
Yes.
Yeah, 3, I think Bryce is right on that, because 3 minus 1 is 2. And of course, absolute value of 2 is 2. Plus 3, yes. So yes. And yes, 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 right? Yes, yes. So we have 3, 4, and 5 that get marked. So that works out. So that's what this one looks like here. Okay? Now I want you to go ahead and work out number 2 while I attend to class administrative duties. everybody's here today. That's excellent work. Okay, for number 2, what does that look like? We start out with no, don't we? Because if we take -5, is that right? So we take -5 plus 1. Well, -5 plus 1 is -4. Absolute value of -4 is 4, and 4 minus 2, is 4 minus 2 less than 1? No, greater than 1. So where do we see a yes here? If we plug in 4, let's try, I want to try this one too though. If we plug in -4 plus 1, that's going to be -3. Well, -3, that's going to be +3. 3 minus 2 is not less than, but is equal to, right? And then we have yes up until when? Until 2. I'll try 1. 1 plus 1, no, because 1 plus 1 is 2. 2 minus 2 is going to be, yeah, it's still going to be less than, right? And then 2, 3 minus 2 is still equal to, but now if we take 3, we get 4 minus 2, which is greater than, so no, 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 right? Is this what you got for this thing? So -4 all the way up to 2. Now what was it I said to you to help you remember these things? What it was? 6 words. 6 words. 2 sets of 3 words. Blank, 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 comma, blank, blank, blank. What are the words? More is or. You remember me saying that?
We didn't get to the more is or part.
You didn't do that? Less is nest.
You got to the less is nest, but you didn't get to the more is.
Oh, okay. So I didn't get as far to be able to do
We
it.
just
So.
got to that less is nest part.
Oh, really? Okay. All right. So the less is nest, you remember a little bit of that. What's happened is, so when you say or and you have greater than, you're going to have 2 intervals of solutions. Where you have a less than, like in this case, you're going to have a single interval of solutions between 2 extremities. Okay? Well, that explains, if I think about it, that's why. Didn't quite go far. Okay? Questions about that? Are we okay on that? Let's go ahead. Now we are to solving these inequalities graphically. And situation, how do we solve graphically? We got to solve these. What's our strategy for solving these graphically? Pardon me, what'd you say?
You split into 2 parts.
Yeah, split it to, thank you, Marcus, all right, yeah. So if we set one side, this f of x equals 2 absolute value of x, and g of x is equal to 6, we can graph both of these and then analyze where the graph of this function is less than or equal to the graph of that 6 function, right? So here, the 6, that's pretty simple, right? So this is what our 6 looks like. And then what does the graph of this thing here look like? This 2 absolute value of x, what does that look like? What is our vertex for this one? 0, 0, right? Why 0, 0?
There's nothing outside of the...
Yeah, there's nothing outside, right? There's nothing outside, which means k is 0, and also there's nothing plus or minus inside the bracket either. So that's 0, 0 right there. And then what is our slope of this thing going to be? 2. Up 2 over 2. So just like this. And then like this, okay? So what are the solutions here? And these ones here, what did I call these things last week, remember? I call it boundary points. Because these points here establish the boundary of our inequality, the boundaries of our inequality, right? Now, is this going to be more is or less is nest? Less is nest. So less is nest, we can just take this right here, and we can say, okay, the x values will nest in between x equals -3 and x equals 3. Is that right?
Wouldn't it be greater than or less than or equal to?
Who said that? Okay, that was Bryce. All right, Bryce. Yeah, Bryce is 100% right about that. Bryce asked if we wouldn't have equal to sign. Yeah. Why is Bryce right about that? Yeah, because of this up here. We got to make sure that we have the same type of sign set up. Okay. So, and could we write that in another type of notation?
Yeah.
We write that interval notation too, right? So these would be a couple different ways of writing our answers to this. Okay, I want you to go ahead and look at number 4 and do number 4 and see what we get. Jay, are you a big Johnny Cash fan?
I used to be, but I haven't listened to it in a while.
Yeah, let's do it in a while. So you were enough a fan to have a t-shirt.
I can't be Jay anymore because Jay's in here.
You gotta be Jay?
Yeah, I can't be Jay.
So we gotta have Jay and Jaden.
Yeah. You can call me Jay Wise though.
Jay Wise?
Yeah.
Jay Wise, okay. Yeah, Jay, I think you'll like this class. This class can be quiet, but they do really good about working right until the end of the day. Pretty well, which is commendable. It's not the easiest thing in the world to do. And we got Riley over there, and Riley provides like fragrance to the room.
He says stuff all the time, but doesn't admit to it.
Yeah.
No, Riley had a little accident last Friday,
Uh-oh, did you hear so?
but it kind of,
Oh, yeah, I remember that.
no, because we could still smell the cologne today. It was pretty good. Riley, I've had compliments on the cologne today.
Did you dress up like Mr. Griffin today?
What's that?
Did you dress up like Mr. Griffin today?
Kind of, yeah. That's part of it. But I like to dress up like this anyway. It's just, but Mr. Griffin likes dressing up like that every day.
Yeah. How y'all talk about y'all's band yet?
No, I haven't. I've talked about NHS with him though.
Yeah, he said he's real excited. Like he's got to start figuring out the first song names. He said he's thinking about playing "Hello Darkness, My Old Friend."
Oh, okay.
Yeah.
We do the Man in Black too, that's a song. All right. So did you do this one over here? What did you get as your solutions for 4? Did you get those already?
-2, -1,
So just as X, it's going to be OR, right? So X is greater than what?
1.
1. Or X is less than
-1, or something like that.
Yeah, I don't think it's symmetric. I don't think it'll be -1. Well, let's go ahead and work it out and see what we get. So here we have, according to what Marcus encourages us to do here. You graph this here. And then what's our vertex for this thing?
-3, or no, it's
3,
-2.
3, -2.
-2.
So now our slope is going to be 1, right? Why is the slope 1?
Because X is less than.
And nothing for the X. So what it is, the standard form is going to be like f of X equals A times X minus H plus K. And here, we don't have any number in front of this, so A is 1. So I'm looking at my boundary points. I'm looking at, looks like 2, comma, -1, and 4, comma, -1. So I'm not getting these solutions here. What solutions am I getting?
-, like that.
I got X is greater than 4,
Yeah, and then X
or
is
X is less than 2. And do we need to have an equal then to this thing here?
No.
No, so this will be our answer here. And interval notation is going to look like, I think it's going to be negativity 2 union 4 to infinity. I don't know which way you like better. Which way do you like better, the way on top or the way on bottom? You like the top one better?
Yeah.
Yeah, to me, yeah, they're both good. Yeah, I can see that. Okay, next. I want you to work on 5 and 6. Try your hand at those and we'll go over them shortly. How's that? What'd you get for this one here?
Negative 2 and 2.
-2, 2. So you're saying like this. Two. Is that what you got? Okay. We'll go ahead and graph this right side here. So here's our 3, right? So that'd be like g of x is equal to 3. And then we have our, what is our vertex going to be? 0, 2. And then our slope is 1/2. And over here, -1/2. So to me, it looks like our boundary points are going to be -2, 3, and 2, 3, right? And so, yeah, that's going to be it, isn't it? And then we can have an interval notation. We could write this as -2, 2. So we can write it that way too, okay?
So it wouldn't be equal to.
Yeah, so Jay asked if the thing will be equal to at all. Do we see any equal to here? No, we don't. So that basically we look back and see if these have to be similar to what we have over here, okay? Good question. All right. Okay, did you work out this one too? Addie, what did you get for this one?
-2 is less than x.
So -2 is less
Oh
than,
no, -4 is less than or equal to x is less than or equal to 0.
-4 is less than or equal to x. So -4 is less than or equal to x, and that's less than or equal to 0.
I think it's greater than.
Yeah, here's the thing about it is, these numbers might be right, but remember, what is this going to be? This is more is or, right? So this one here probably is not right because of that, okay? But we'll examine it and check it up, because it could be the extreme values are right, the critical numbers here may be right, and we just have to make some adjustments. We can do that, right? So we go ahead and put the -2 in place here. If I could draw halfway straight, that'd be better. Okay, that's halfway straight. Okay, and then we have, what's going to be our vertex for this thing?
-2, -4.
So Jay says -2, -4, is that right? Yeah, looks right. And then our slope is going to be 1. And then -1 over on this side. So I think Addie is right about these critical numbers, but we have to just make some adjustments here, don't we? What is it going to be? It's going to be x is greater than or equal to 0, or x is less than or equal to -4. And if we go ahead and make this into an interval notation, we go like this. So those will be our answers to this one right here.
Would you use brackets after the 4 and before the 0?
Pardon me?
Would you use brackets before, no, after the 4 and before the 0?
Okay, Ben is making a suggestion. Would we use brackets here? Yeah, we would.
I'm confused.
Wouldn't
How do you know that x is greater than 0? That part just makes sense to me.
Wouldn't it be less than or equal to 0?
Because how can x be greater than 0 but less than negative 4?
And it's in between -4 and 0, so wouldn't it be less than 0?
It'd be less than 0.
And greater than or
Yeah,
equal?
so I got, this part is right, but x, no, wait a second. X is greater than or equal to 0, and x is less than. Yeah, so that's right. X is greater than 0, which is this, or x is less than or equal to -4.
Oh, okay. Never mind.
So it's, yeah, but you have to kind of look at it, because I actually, because when you said that, I actually made that mistake in an earlier class today. But you got to kind of look at it carefully and just sort of think of it logically. Yeah, that is right, but look at it critically. Do you see that? Do you see that it's right?
No. So it's like, so you're looking for the, like, the x would be greater than or equal to 0.
Yes.
So that means like everything outside of the absolute value graph. is
What it
you're
means, you're
for.
looking for where this v-shaped function is greater than this line here. So if you look at it, if we scope in on it like this, in this blue box is where the thing is above this line here, which happens when x is greater than or equal to 0, or less than or equal to x equals -4. So -4, comma, -2, and 0, comma, -2, those are the boundary points.
Yeah, I think I always get confused because I'm used to the line, like the
You're used to
line,
the
the
number
line
line?
where I understand.
You're used to the
because I
number
can-
line.
Yeah, because I can see like the blank space, I guess.
Yeah,
But
so
on
you
the
have,
graph, I can't see the blank space that we're not.
yeah, so what it is, sometimes what you can do, if it might be helpful to you, you can actually build your own number line right below it here and put like a 0 and a -4. Then you could look and say, well, this is below the line, but it says greater than. So greater than is going to be on the extremities, and it says equal to, so it's going to be like this. Because we can see those are solutions, right? And the only question now, is this going to be between those numbers or outside of those numbers? Well, this tells you, the greater than tells you we're going to be outside of those numbers. So that's what it'll look like on a number line. I don't know what else to tell you. Is that going to be okay?
I got it.
Can you? Now, 7 through 10 are ones where essentially they're graph matching problems, where you look at them and say which one is which. So I want you to go ahead and look at 7 through 10 and work those out. Jay, do you have a calculator?
Yeah, a little bit.
You got your own calculator? Okay, good. All right, what'd you get for these?
I got 7 C.
7 is C?
Yeah, that's what I got.
Yeah, let's check that. Okay, your vertex is going to be along the y-axis and you're going to be down 1. Slope is 2. So that, to me, that looks good, right?
I think 10 is A.
Okay, who else has one? So 8 is D. Connor says 8 is D. Let's check that out. So we have our vertex at -1, comma 0. Is that right? Yeah.
-1 comma 0.
Or 1, comma 0.
Yeah.
1, comma 0, right? 1, comma 0, because that's x minus h. So that's exactly right. Okay, good, good call. Okay, what else?
10 is A.
B.
So 10 is A, Jay says. Let's go ahead and check that out. So we have, yeah, +1, and we have like 0, comma 1 as our vertex. Yeah, that's right. And then by process of elimination, 9 is going to be B, right? And it's going to be H is -1. So is everybody good on that? Okay. Let's go to number 11. And now it says solve algebraically. So we're just going to do what we're trying to do is get this isolated, this absolute value bracket. We're solving for the absolute value bracket, and then we're going to use our more is or less is nest deal, right? So here, the first thing we do is subtract 3. So we get 2 times absolute value of x minus 7/2 is greater than 1. And then divide by 2. So we get absolute value of x minus 7/2 is greater than 1/2. Then what? Yeah, one's positive, one plus. Let's do the positive. If we have x minus 7/2 is greater than 1/2, and what's the other one going to be?
Same thing, but -1.
Yeah, same thing, but -1/2. So x minus 7/2, and what do we do with the inequality symbol? We switch it now, right? So now that's what we have, and we can just solve for x. So plus 7/2. What's 1/2 plus 7/2? That'd be 4, right? So we have greater than 4. So we're going to be like this. And what about this one? Plus 7/2. And I got this, hang on a second, this should be -1/2, shouldn't it? I don't know why I wrote -2. Anyway, -1/2 plus 7/2 is 3. So here we have less than 3. And interval notation, which is going to be like this, infinity 3. So those would be our answers, or okay, what I want you to do with remainder of class time is finish up working on 12 and 13, and we'll call that a day for us. How's that?
Yeah.
Be able to do that?
Plan, boss man.
That's the plan, all right. I will tell you on 12, you're going to get a nesting deal. And what are you going to get on 13? More is or, okay? So just what to look out for.